Okay, these notes are about molecular formulas. Okay, molecular formulas are formulas that tell you exactly how many atoms of each element are in the compound. Now, they are not the lowest whole number ratio usually, although they can be sometimes, but most of the time they're not. They apply only to covalent compounds, not ionic. Ionic compounds always have to be empirical formulas, so they can't be molecular formulas. You can calculate the molecular formula of a compound if you know the empirical formula and the molar mass of the compound. Now, there's a little, I guess, equation, I don't know if you want to call it equation, a little expression that shows you what to do. So we're going to put an N, which your N is your whole number multiplier. This is the number that we're going to be multiplying each element by. So you calculate that by taking the molar mass of the molecular formula, over the empirical formula mass. Now, this will be given to you. So this will be given in the problem. This you will have to calculate using the periodic table. Just like we've been doing molar masses this whole unit, you calculate the molar mass of the empirical formula. The molar mass, though, does have to be given to you, otherwise you can't do the problems. Okay, so let's look at the first example. What is the molecular formula of a compound that has an empirical formula of CH and a molar mass of 78.12? So this right here is the molar mass. Whoops, I can't write today. Molar mass of the molecular formula. Okay? We have to calculate this. Okay, so CH is, well, it's 12.01 plus 1.01, which is 13.02 grams per mole. Okay? So now at this point in time, we need to calculate the little n, the multiplier. So n equals 78.12 divided by 13.02, which rounds to 6. So now we have C and an H, and we're going to take this 6 and put it here and here. So we now have C6, H6. Okay? Now, if there was numbers, in fact, if there was, let's say we had C2H3, say that was your empirical formula. And your multiplier, let's say your N was maybe 3. Okay? You would do C, and then it was 2 times 3, and then H, 3 times 3. So you would end up with C6H9. Okay? So this multiplier here multiplies whatever little numbers. If there's no numbers, then that's the number you stick there. But if there's other numbers, you actually have to multiply. So hopefully that clears that up. Okay, now sometimes you have to calculate the empirical formula first. That means it's not given to you, but maybe the percentage of all the elements are given to you. Then you can calculate the molecular formula. Okay, now let's look at this example. What is the molecular formula of a compound made of 40% carbon, 6.7% hydrogen, and 53.3% oxygen? And I forgot to put in here earlier, but the molar mass is, where'd it go? 180 grams per mole. Okay, you do need that. Okay, so we're going to start with carbon. So we have 40.0 grams of carbon over 12.01, and this gives us 3.33 moles. And then your hydrogen is 6.7 over 1.01. This gives you 6.63 moles. And then your oxygen is 3.3 over 16, and you get 3.33 moles. And of course we're going to divide everything by 3.33. And we get 1, 2, and 1. So our empirical formula is CH2O. Now, the molar mass for this, if we add everything up, so this is 12.01 plus 2.02 plus 16, and when we add that up, it's 30.03 grams per mole. So now we need to take the molecular formula mass, so the 180 over 30.03, and that's going to give us 6. So our molecular formula is C6H12O6. Okay, glucose. Cool. Okay, so example number 3 is, what is the molecular formula of a compound that contains 5.56 grams of carbon, 0.94 grams of hydrogen, and 18.50 grams of bromine, and has a molar mass of 216 grams per mole? Okay, so once again, we're going to do it just like we did the last example, only instead of percentages, we're going to use our grams that we're given. So carbon is 5.56 over 12.01, and that gives us 0.63 moles. And then hydrogen is 0.94 over 1.01, and that gives us 0.931 moles. And then your bromine is 18.50 over 79.90, and that gives us 0.232 moles. Of course, your lowest moles is 2.232. So this gives us 2, this is 4, and this is 1. So your empirical formula is C2H4Br. Now, when you add that up, and I'm not going to go ahead and do the 2 times 12.01 plus 4 times 1.01, I think you get the idea. The molar mass of this is 107.96 grams per mole. Now, you're given a molar mass of 216, and 107.96 is close enough to 108, and it's a 2. So we get C4H8Br2. Hopefully that was easy enough for you. We'll do some problems in class. We'll do a warm-up first. And hopefully you guys get this. So I will see you everyone tomorrow. Bye.